Okay, let's take our knowledge of polynomial functions and their zeros, and we're going to turn this around and go backwards. So I want to write a polynomial function of degree 3 that has a 0 of multiplicity 2 at x equals 2 and a 0 of multiplicity 1 at x equals negative 3 and a y-intercept of 9. Now, I can't remember if this has come up before, but this phrase that x equals 2 is a root. That's another way of saying 0. So in this context, root means the same thing as 0. Okay. So what do I know about this function? Well, let's give it a name. We're going to call it p of x. And I know that it has a root, or a 0, of multiplicity 2 at x equals 2, which means that x minus 2 is a factor, and it's a factor that is squared. And we have a root, or a 0, at x equals negative 3 of multiplicity 1, which means that x minus a negative 3, or x plus 3, is a factor with an exponent of 1. Now, I haven't yet used that y-intercept, and in fact, if I test this, I'm not going to have a y-intercept of 9, which means I need a leading coefficient that will change that. So I'm just going to put a placeholder in there. But this statement that there's a y-intercept at 9 really means that p of 0 equals 9. So p of 0 equals this unknown times 0 minus 2 squared times 0 plus 3, which means some unknown times negative 2 squared times 3. And that is, well, negative 2 squared is 4. Times 3 gives me 12a. Now I also know that that needs to equal 9. So this leads me to my leading coefficient is 9 over 12, which reduces to 3/4. So my polynomial that has a 0 of 2 with multiplicity 2, a 0 at negative 3 with multiplicity 1, and a y-intercept of 9 is 3/4 times x minus 2 squared times x plus 3. All right, let's take a look at another one. This time, I'm just given a graph and asked to write the equation. Well, I can see a few things. I can see I've got a 0 here at negative 2, a 0 here at negative 1, and a 0 here at 3, and a y-intercept of negative 3. Okay. But the graph looks a little funky here. So remember what this means. If I just look at this shape here, that kind of looks like an x to the third. So if we look at these factors, and this kind of just looks like a straight line. And this kind of just looks like a straight line. So the factor that goes with this 0 at negative 2 is likely a factor, actually it is a factor, of multiplicity 1. The factor that goes with the 0 at negative 1 is also of multiplicity 1, because the graph going through those two factors looks like a straight line. Now this guy that goes through here, this looks like a cubic. So the factor that's associated with this 0 has got to have a multiplicity of 3, because it looks like an x to the third. So my function, which I'm just going to name p, is going to be some leading coefficient times x plus 2 times x plus 1 times x minus 3 to the third power. And I know p of 0 needs to equal negative 3, which means that a times 0 plus 2 times 0 plus 1 times 0 minus 3 to the third power equals negative 3. So negative 3 is going to be equal to that a times 2 times 1 times negative 3 to the third power. Now negative 3 to the third power is negative 20. Okay, let's do this differently. Let's go ahead and just divide through by 2 times 1 times negative 3 to the third power. So a is negative 3 divided by 2, and I'm going to drop the 1 because anything times 1 is just the thing, over negative 3 to the third. Well, this negative 3 will cancel one of those, which makes that a negative 3 squared, which means my a is actually negative 1 over 2 times negative 3 squared, which is 1 over 2 times 9, which is 1/18. So my polynomial is 1/18 times x plus 2 times x plus 1 times x minus 3 to the third power. I hope this has been helpful.